Welcome to the deep dive. You send us your docs, your research, basically the stuff you're trying to wrap your head around.
And we dig in.
We dig in, yeah, and pull out the key insights you
We
need.
get you up to speed fast.
Exactly. So today, we've got a really interesting one. Two documents, a business note and a strategic blueprint investment memo.
Both focused on a company called Shizero Energies.
Right. And our mission today, pretty simple. Understand their strategy, their game plan for, well, shaking up the battery material supply chain.
And hopefully give you, the listener, a really clear picture of what they're trying to do.
Let's jump in. What's the big picture here? What's the problem Shizero's tackling?
Well, it starts with this huge global shift, doesn't it? Everyone's moving towards electric power.
Right. Away from fossil fuels.
But the materials needed for all these batteries, that's becoming a major sticking point.
A bottleneck.
A big bottleneck. And there's this heavy reliance on just one main source for a lot of critical stuff.
Which creates risks, obviously.
Correct.
Supply chain vulnerabilities.
Definitely. Now bring India into the picture.
Okay.
India actually has the world's 5th largest reserves of manganese.
5th largest, wow. And within India.
The state of Odisha. It holds something like over 44% of India's total manganese. Huge concentration there.
Okay, so lots of manganese in Odisha, but there's a catch, isn't there?
There is a big one. Over 60%, maybe more, of this Indian ore is considered low grade.
Meaning?
Meaning traditional industries like steel manufacturing, which uses manganese, they often just discard it or don't really use it efficiently.
So a massive potential resource is just kind of sitting there underutilized.
Precisely. And that perceived limitation, that abundance of supposedly low-grade stuff,
Yeah.
that's exactly what Shizero Energies sees as their strategic opportunity.
Okay, so they're flipping the script. What others see as waste, they see as potential value.
Exactly. Not a hindrance, but a massive untapped local resource.
Okay, let's unpack that.
Yeah.
Because their approach sounds different, not like a typical miner just digging things up.
It's very different. They're not starting with the resource extraction itself. They're starting way downstream.
With the customer.
Yes. With the end customer, the battery manufacturers, the energy storage companies. What do they actually need?
So it's a backward approach, kind of.
You could call it that. They figure out the exact specs, first purity levels, particle shape, performance characteristics, all the stuff battery makers care about.
Things needed for better batteries, basically. Longer life, faster charging, that sort of thing.
Right. And then they work backwards to develop the technology to actually produce that precise material.
And they're doing this while thinking about local supply chains in India.
Absolutely. The economics have to work locally. Their whole philosophy seems to be this blend of resource realism,
Knowing what they actually have to work with.
customer clarity,
Knowing exactly what's needed.
and technological precision, using the right tech to connect the two.
Okay, let's talk about that technology. They see the low-grade manganese issue differently, right?
Totally. They frame it as a materials science problem.
Not a mining problem.
No, the issue isn't getting it out of the ground. It's that the old ways of evaluating and processing it, 20th century methods, just can't upgrade it enough for modern batteries.
So they needed a new approach.
Yeah, what they call a first principles approach, like physicists starting from scratch.
Asking fundamental
It's
questions.
like, what's the absolute purest potential of this manganese? Forget the grade, what can it become?
Now, what do the battery companies really want? Down to the specifics, particle size, density, shape.
Exactly. Purity thresholds, all of it. And then the crucial question, can we get that specific material from this abundant, unused Indian ore?
Using modern chemistry. Hydrometallurgy.
And their answer, based on their research, is yes. By fundamentally shifting how you view the material. It's not a bulk commodity anymore, a precision-engineered intermediate, something designed for a specific purpose.
And how are they actually doing the engineering? They're not doing this alone, are they?
No, definitely not. They've got a major collaboration going with CSIR IMMT.
That's India's top metallurgy research institute.
Premier Institute, yeah. And they're not just licensing old tech, they're co-developing a whole new scalable platform.
Tailor-made for this challenge.
Precisely. It's not off-the-shelf stuff. Their R&D focuses on some pretty advanced chemistry.
Like what?
Well, things like selective leaching, carefully pulling just the manganese out of the ore, leaving behind the unwanted stuff like iron.
Okay, getting the good stuff out cleanly.
Right. Then controlling precipitation and crystallization very carefully. This is key to getting phase-pure compounds, the right chemical structure.
So purity in the right form.
And morphology tuning. That means controlling the actual shape and size of the manganese particles.
To match exactly what the cathode precursor makers need.
Exactly. And they can even create different final chemical forms, carbonate, sulfate, oxalate, oxide, whatever the specific buyer needs.
Wow, so it's highly customized, not just manganese, but manganese specified by customer X.
You got it. Because different battery companies have unique recipes, unique requirements.
The documents mention crystal structures, surface energies. It sounds incredibly detailed, like semiconductor manufacturing.
That's the analogy they use in the business note, actually. Just like chips move to smaller, more precise nodes,
Yeah.
battery materials like manganese need to evolve from just a bulk mineral to a highly engineered precursor.
To enable better batteries down the line.
That's the idea. Unlock that next level of performance.
Okay, so summing up the tech side, it's advanced chemical engineering, materials customization, deep R&D.
And a really tight feedback loop with the battery OEMs, the manufacturers.
They're basically aiming to build, the fabrication layer for India's critical minerals.
That's the phrase they use, building tech that's forward compatible, ready for future battery chemistries too.
Which brings us back to their business model. All this tech is driven by
The customer. Always the customer first. They're not building a giant plant and hoping someone buys the output.
no, build it and they will come.
Definitely not. They're talking to potential buyers right now. Sodium-ion companies, lithium-ion companies.
Before scaling up production,
Way before. They're sending out validated samples from their R&D work
getting feedback.
and asking really specific questions. What particle size do you need? What density? Spherical shapes? Angular? What's your absolute minimum purity?
And also practical stuff, like where are you buying from now? What price are you paying?
Right. All that market intelligence.
So this lets them essentially co-develop the supply relationship,
Exactly. They can lock in specifications, potentially even future orders.
which de-risks the whole thing.
Massively. It means when they do invest in building capacity, it's capital efficient. They know they're building something the market actually wants, technically relevant.
Makes sense. Now, they're starting with manganese, but is that the end game?
No, the documents are clear on that. Manganese is just the entry point.
It's first step.
Yeah. Their bigger mission is to become a globally respected supplier of critical battery materials more broadly.
Aiming to help create those faster charging, longer lasting batteries everyone wants.
Right. They see this perfect alignment happening. You've got the raw material availability in India.
The manganese?
You've got the strategic geopolitical push for supply chains not dependent on China.
A huge driver right now.
And you've got their ground-up advanced technology ready to meet that need.
It's quite a convergence.
And looking even further ahead, they mention things like urban mining.
Getting materials from waste.
Yeah. And battery recycling, too. Applying the same core principles, customer focus, materials science to those circular economy streams later on.
But they stress this isn't just a moonshot, right? It's a viable business.
Very much so. They position it as a practical industrial business being built step by step.
Okay, let's touch on the strategic blueprint memo specifically. What does it add?
It really hammers home that window of opportunity point, the electric transition, the supply constraints. It's happening now.
And the untapped potential in Odisha.
Yes, that low-grade ore just sitting there because the right tech was missing.
It also lays out these truths guiding them.
Yes, sort of their foundational beliefs. 1, manganese is essential for batteries. 2, the world needs alternative suppliers. 3, Odisha has the material but lack the tech. 4, customers will always want better batteries.
Pretty straightforward logic.
And it highlights that CSIR-IMMT partnership again, developing that customized process. It's not generic.
Tailored beneficiation, tailored chemical extraction.
Right. They call it lab-to-market engineering, constantly characterizing the specific ore, tuning the process, matching it to customer specs.
Purity, particle size, shape, all dialed in.
And they mention their progress land secured, infrastructure planning, ongoing R&D, field tests with ore samples.
Manageable steps.
But always reinforcing the core method. Finalize buyers and applications first, then build the facility.
What about near-term plans? Funding.
They mentioned needing an initial investment, it looks like around 30 lakh to get the ball rolling.
For what specifically?
Primarily for the technology transfer from CSIR IMMT, validating all their data rigorously, and getting those crucial buyer certifications, locking things down.
And they have a timeline.
They're aiming to be a first revenue battery materials company by Q1 2026.
Ambitious.
It shows focus, yeah. They want to move quickly.
What about risks? Do they address potential setbacks?
They do. They talk about worst case scenarios, what if the big investment doesn't come through right away or specific grants don't materialize?
Mm-hmm.
Their answer is they're still committed. They'll build it anyway, maybe starting leaner,
How?
perhaps focusing initially on battery recycling, which might need less upfront capital, and then scaling up to ore processing later as revenue comes in.
So resilience seems baked into the plan, a long-term commitment.
Definitely. They see themselves building the foundation for India's battery materials industry. It's a strategic long-term play.
Okay, let's bring it back to the listener.
Yeah.
Why should you care about Shizero Energies?
Well, their story really ties into huge global trends, doesn't it? Energy independence, for one.
Security of supply.
Exactly. Technological innovation in sustainable materials. And, of course, the massive growth in EVs and energy storage. Everyone's feeling that.
And Shizero represents a potential new way forward.
Potentially, yes. A possibly more cost-effective, stable, geographically diverse alternative in a supply chain that's, frankly, under a lot of pressure right now.
So summarizing Shizero's whole approach,
Yeah.
what's the core idea?
It really boils down to leveraging this abundant, local, but underused resource.
The low-grade manganese.
Using innovative materials science, like really advanced chemistry,
Driven by that deep customer understanding.
to solve a critical global need in the battery supply chain. It connects all those dots.
Key takeaways for you listening. What should stick?
I'd say. Number one, that relentless customer-first focus, understanding requirements before building.
Right.
Number two, the deep R&D partnership to create genuinely new technology for this specific challenge.
Not just off the shelf.
Number three, their phased de-risk scaling strategy. Validate, then build.
Capital efficient.
And finally, their long-term vision. Manganese now, but a broader energy materials platform later.
Okay, that gives a really clear picture. It leaves us with a final thought, maybe.
Yeah, definitely. It makes you wonder, doesn't it?
About,
About how many other industries might have similar situations. Seemingly low-value resources, maybe even waste streams,
yeah.
that could actually be unlocked, turned into strategic assets if we just looked at them differently.
Through the lens of advanced technology,
And a really deep understanding of what end users truly need down the line.
what other waste could become valuable with the right approach?
Exactly. What else is being overlooked? Makes you think.